Everyone. Today here we are going to take the derivative of exponential functions. What I gave you before, it was product rule. I gave you product rule, so you have to know what is product rule, right? So I'm just here's something you should really review. Quotient rule, that's what I gave you also. Quotient rules. So product rule, I give it to you here as f multiplied by g prime. It will be f g prime plus f prime g. Quotient rule, if you have f over g prime, then it will be g square g f prime minus f g prime. Then I give you power rules, right? What is power rules? I give you power rules here, and also I give you chain rules, power rules. That is when you have a bracket to the power n, I need to take the derivative of this bracket. It's a bracket to the power n. I put n in front, and here is your bracket, n minus 1. And then I have to multiply by the derivative, whatever inside the bracket. So now we are going to take the derivative of exponential. So what is exponential function means? Exponential functions, if you have by equal, or f of x here, say b to the power x, b to the power x. What is b? B here we call it base here, and this base must be positive, just positive number. So you must have positive number, all right? And x here we call it exponent. Right? So here, if you have, just try to see, if you have b equal e, what is e here? E here is 2.7. If you look your technology, you have e, which is 2.7. Then you will have your exponential functions, f of x equal e to the power x. And this one we call it natural exponential functions. So that is natural exponential functions, right? So now we are going to take, what is the rule to take the derivative? So let me now give you a general rule. What is the general rule for exponential? If you have y equal to b, and the b here is to the power, so that if that is your f of x here, I call it g of x, right? So I'm going to take b to the power f. Your exponent here is f of x, not x here. Here you have x, here you have x. No, I have f of x like a general exponential functions. B to the power f of x. Your b again we call it base and positive number. F of x, that is our exponent. Turn out the derivative y prime, which is dy by dx or dg by dx, is nothing but the derivative of this here, the derivative of this, which is b to the power f. It turned out is nothing but b to the power f. Derivative any exponential is nothing but will be the same, multiplied by ln b, multiplied by the derivative of the exponent, So here, this f prime here, that is your derivative of the exponent. Derivative, just write it, derivative of your exponent. So that is exponential. So if you have any exponential function, the derivative of this is nothing but b to the power f. I need to take the derivative of this. It will be exactly the same. Is this one exponential? Yes. How did you know? Because b a positive number raised to the power f of x, and then the derivative should be exactly the same, b to the power f, multiplied by ln b, multiplied by f prime, which is the derivative, whatever inside the bracket. So let me give you here what happens if you have b equal e for natural exponential functions. Then what do you have? So your y equal g of x, which is e to the power f, f of x. Then the derivative y prime or g prime. What is the derivative of this? Is this one exponential? Yes. Why? Because e, what is e? 2.7, positive number. So the derivative any exponential should be exactly the same, ln. What is your b here, guys? What is my b? If I compare, what is my b? Oh, your b here is what? Is e. Your b here is e, so it will be ln. Instead of b, what do you have? You have e, and multiply again by the derivative, whatever of the exponent here, derivative of the exponent. But it turned out, if you have to look your technology, ln e is nothing but is 1. ln e is nothing but is 1, and that is, you have seen that maybe in high school, why ln e is 1, because ln e here is nothing but is log base e, log base e of e, that is equal 1. Because what is the definition of log? E to the power what? To get e to whatever inside here. So e to the power 1, so here you get 1. Or just use technology. If you use technology, you will have ln e is nothing but is 1. So now when we return back to this, the derivative of e to the power f is nothing but, it will be e to the power f multiplied by f prime. What is f prime? The derivative of your exponent. The derivative of your exponent. Let me give you some example here, and then we can keep continue. Example number 1, if you have f of x here equals, say, e to the power 2 minus 3x, e to the power minus 3x. So now I ask myself, is this one here, it's exponential one? Yes. How did you know? How did I know exponential? Because e is 2.7 to the power, that is my exponent. So now what is the derivative of the exponent here? Exponential should be exactly the same, and ln, what is my b? Your base. Oh, my base here is e, that is your base, ln your base, whatever it is, your base, and multiply by the derivative of the exponent. What is your exponent? 2 minus 3x. What is the derivative of this? Just take the derivative. ln e is what? Is 1. So you have 2 minus 3x. What is the derivative here? This one means that's 1. Here when I use technology is 1. So what do you have in the middle? Minus. So it will be the derivative of the first term minus the derivative of the second term, right? Because you have in the middle minus, then you take the derivative term by term. That is 2. What is the derivative of 2? That's a constant. Derivative of any constant should be 0. You have 3 here. I can grab it outside of my derivative. So what do you have left? X prime. What do you have left? X prime. What is the derivative of x prime? The derivative of x prime here is 1. The derivative of x prime is 1. So what did you get here, guys? You get negative 3 from here. Multiply by this, which is e to the power minus 3x. And that is your derivative of this exponential, and just leave it like this. All right, another example here, example number 2. If you have g of x equal to, equal to 8 to the power 3x. 8 to the power 3x. I need to take the derivative of this. How to take the derivative of this? Turn out the derivative of this here. Is this one exponential? Yes, it's exponential. So what is your b? Your b here is 8. What is your exponent? 3x. So is this one positive 8? Yes, positive number. So I have exponential functions. Derivative of any exponential function should be exactly the same. And ln 8. So that is your constant. B, your b here is 8. Your b here is 8. So you have ln 8, and you have to multiply by the derivative of exponent, which is 3x prime. Derivative of exponent 3x prime. So here again, what is your base? 8. Your exponent 3x. Exponential, so I have to write it the same. And ln b, which is your base, and I have to multiply this by the derivative of the exponent 3x. What is the derivative of 3x, guys? Oh, 3, very good, yeah. So you have here 8 to the power 3x, ln 8, that's a number. That's a constant here. You don't need to worry about it because it's a number. You can use technology to get this number. The derivative of 3x, I can grab 3 out. You have x prime. What is the derivative of x prime? Just 1. The derivative of x prime, just 1. All right? Then you leave it like this. You don't need to simplify and compute ln 8. Just leave it as it is, okay? Without simplify. So now I go another example here, which is, what is the derivative? You have g of x here equal to e to the power x to x cubed, and the whole thing here is to the power 5. The whole thing here to the power 5, right? Is this one here exponential? How many exponents you have? You have 2 exponents. If you have, let us recall here. If you have e to the power, n, the whole thing to the power m, what is that? Do you remember how many exponents you have? 2 exponents. Then if I simplify that, it will be n multiplied by m. Now, what is your a, guys, here? Your a here is e. That is your a. Your base here, e. What is e? 2.7. How many exponents you have? You have 2 exponents, so it will be e. 2x cubed multiplied by 5, which is 10. 2 multiplied by 5, 10. X cubed. So this one exponential function, yes. So what is the derivative of this? Derivative any exponential should be exactly the same. Exactly the same. And the ln b, what is your base? That is your base. Whatever that is your base here, I put circle here, that's my base. And I have to multiply by the derivative of exponent here. That is your exponent, 10x cubed. What is the derivative of 10x cubed? Right? We mentioned ln e here is 1. So you have e to the power 10x cubed. That is 1. And 10, I can grab 10 out. So now what do you have left? X cubed prime, which is 10 e to the power 10 x cubed. The derivative of x cubed is what? 3x squared. Right? You can leave it like this or simplify. How to simplify? Just multiply 10. So you get 30x squared e to the power 10x cubed. And then you leave it like this. And that is our g prime of x. Alright? G prime of x. So now I have some sheet here, one sheet here I need to solve using that. This sheet I posted already, so I need to solve this. Not all, I'm going to solve some of them, or the one that I feel is difficult. Let me solve here e, c. So y equal 1 over e to the power 2x, right? So I need to get the derivative. Differentiate here, it means take the derivative with respect to x. So now, what do you have? You have y equal 1 divided by e to the power 2x. So as you can see, I said 1 divided by. When you hear divided by means you are going to apply quotient rule. Quotient rule. Divided by what? E to the power 2x. E to the power 2x, that is exponential. So which means I have to use quotient rule, and I have to keep in mind I am going to take the derivative of exponential function, which is e to the power 2x. So here you have two rules, quotient rule, because 1 divided by e to the power 2x, and also I have to use exponential rule because I'm dividing by this. So some people try to avoid quotient rule, right? But if you apply quotient rule, it's correct here. Some people they say, well, let us recall here. If you have 1 over a to the power n, 1 over a to the power n, how to take this one up? It will be a to the power negative n. It will be a to the power negative n. So if you take n up, it will be a to the power negative n, and that is our exponent here. So it will be a to the power negative n. So here, what is your a, guys? Your a here is base. Your a here is your base, and what is your exponent 2x? And that is the one I'm going to take up. So if I take this one here up, I try to simplify. It will be, what is your exponent 2x? And here if you have n, take opposite sign. So I have to take opposite sign of 2x. So you have e to the power negative 2x. Right? So now this one become exponential. It's already exponential, but I don't need to use quotient rule here. Now you just apply exponential because e 2.7. So what is the derivative? It will be e to the power, derivative any exponential should be exactly the same. I should exactly write the exponential function the same. And ln, what is my base? Your base here is e, that is your base. Your base, which is e here. I put circle here. And I have to multiply by the derivative of the exponent, which is negative 2x, right? So now, what is ln e here? It's 1. So here you have negative 2x. And negative 2 here, it's a constant. I can grab it outside. So what do you have left? X prime. X to the power 1 prime, which is just 1. That's very good. So you have negative 2 e to the power negative 2x. And that is our derivative. So here, if some people would like to apply quotient rule, is okay. You can apply quotient rule. You will get the same. You get the same one here. So if another way here, another way where you can apply quotient rule and see what did you get. You get the same or you get something different, right? So your y equal 1 over e to the power 2x, right? So that is quotient rule. If you have f over g prime, it will be g square g f prime minus f g prime, right? That is our quotient rule. So what is your f? Your f is 1. What is your g? That is, you have e to the power 2x. So if I take the derivative, apply this quotient rule, g square, which is e to the power 2x square, and then g, which is e to the power 2x, multiply by f prime, which is 1 prime here, minus e to the power 2x prime, multiply by 1. What is 1 prime? What is 1 prime? 1 prime is what? Is 0, because it's a constant. So this term becomes 0. It's a constant. So what do you have here? And you have e to the power 2x prime. What is, we have negative sign here outside, so we have negative sign. Down here, e to the power 2x. How many exponent you have? 2 exponent. Then you multiply those together. 2x multiplied by 2, you get 4x. And here, what is the derivative of exponential 2 to the power 2x? Derivative any exponential should be exactly the same, and ln the base, which is e, and I have to multiply by the derivative of the exponent, which is 2x prime. 2x prime. So now, if I simplify this, you have negative e to the power 2x. ln is, what is ln e here is 1. Derivative of 2x here just 2. I take 2 out. You have x prime. What is x prime? Is 1. And here you have 4x. So how to simplify this? Recall, if you have a to the power n, recall here, if you have a to the power n over a to the power m, then it will be n minus m. Negative 2, that's a constant. I leave it as it is, negative 2. So what do you have? You have e to the power 2x over e to the power 4x. So what is your n? Your n here is 2x. What is my m? 4x. So this one should be negative 2 e to the power 2x, which is n, minus m, which is minus 4x. If I simplify this, you get negative 2 e to the power negative 2x. And that is exactly, look what you have up here. Here, look what you have here. This one here, negative 2 e to the power negative 2x. And here also, if I simplify your quotient rule, you will get exactly the same. You get exactly the same. All right. So let me solve here some of this problem, and then continue next time how to get log. So here let us solve the first one. All right. So how to solve the first one? Here you have e to the power 2x minus x squared. Right. So here is this one exponential? Yes. How did you know exponential? Because you have e, which is 2.7 to the power 2x minus x squared. So what is the derivative in exponential? Should be exactly the same. Exactly the same. Multiply by ln. What is your base? That's called base here. That is our base. It will be ln e. And then I have to multiply by the derivative of what here? The exponent. What is my exponent? Oh, 2x minus x squared. I have to take the derivative of this. Then what do you have? You have e to the power 2x minus x squared. ln e here is 1. Now, what is the derivative 2? What do you have in the middle? Minus, which means you take the derivative of first term minus the derivative of second term. I'm taking the derivative term by term. So you have 2x minus x squared. I can grab 2 out. Then you have x prime. What is x prime? What is x prime? Is 1. Very good. Yeah. What is the derivative of x squared? You have 2x. Then I leave it as it is. I leave it as it is. So let us solve this b. G of x. What is g of x here? G of x equal 5 to the power x to the power 5, right? X to the power 5 plus e to the power 3, right? I need to take the derivative of both sides. So you have here 5 to the power x to the power 5 plus e to the power 3 prime. I need to take the derivative both sides, right? What do you have in the middle plus? What do you have in the middle plus? If you have in the middle plus means you take the derivative term by term. So I have to take the derivative of first term plus the derivative of second term plus the derivative of the third term. Now I look to each term. Oh, you have 5 to the power what? X. What is 5 to the power x? 5 to the power x means it's exponential. How did you know it's exponential? Because 5, that's your base. Your base is what? Is a positive number, which is 5. So now that is derivative of exponential. So how to get the derivative of any exponential should be exactly the same. And what is your base? Your base is 5. Then it will be ln b. What is b? 5. And then I have to take the derivative of the exponent. What is my exponent? X. Now, for the second term, what do you have? Is this one exponential? No. Why? Because your base here is what? Should be positive number. Your x is what? That is your unknown, x. So this one, x to the power 5, we call it polynomial of degree 5. Polynomial of degree 5. So what is the derivative of polynomials? That is shortcut formula, which is you put 5 here. That is your n, 5 in front, and then reduce 5 by 1. Right? So I put 5 in front. That is polynomial. But this one exponential. Exponential because you have a constant or positive number raised to exponent x. But here your unknown x raised to your exponent here just a number. So that is called polynomial. But this one we call it exponential. Right? So you can write this term, the first term exponential. Right? Because your base is positive number. The second term we call it polynomial. This term we call it polynomial. What about the last term? The last term here, it's a constant. E, look what you have, e to the power 3. Square root of e. What is e? E here is 2.7 to the power, almost 2.7 to the power 3. So you can use technology, you will find that it's a constant. So now, what is the derivative of any constant? The derivative of any constant should be 0. The derivative of any constant should be 0. So that is our derivative. Simplify. You have 5. You have 5 to the power x. 5 to the power x. ln 5, you just leave it like this. You don't need to use technology to compute it. X prime, what is x prime? X prime is 1. And here what you have? 5x to the power 4. 5x to the power 4. And that is our derivative, and you leave it like this. You leave it like this. Alright? So now let me solve. Maybe I solve the last two here, right? And then you can try the rest here. I'm providing the key solution for this one. E, you have y equal 1 over e to the power t minus e to the power negative t, right? So you have 1 divided by e to the power t minus e to the power minus t. So when you hear divided by, means you are going to apply quotient rule, because 1 divided by quotient rule. So I'm not going to use quotient rule. If I can avoid it, then it will be nice. So now how to recall? Let us recall here this rule. If you have 1 over a to the power n, let me write it here, 1 over a to the power n, then that is, it will be a to the power negative n. Your exponent here, take it up, take opposite sign. Inside a, I could write e to the power t minus e to the power minus t. What is your n? That's a bracket here, a bracket to the power 1. Whatever under here, down here, the term that you have, e to the power t minus, the whole bracket to the power 1. So if you take the bracket, what is my n here? Your n is 1. If I take 1 up, then it will be e to the power t minus e to the power minus t to the power what? Negative 1. So you have a bracket, I took it up, you have take opposite sign, which is negative 1. Now, since you have a bracket to the power n, that is power rules. If you have a bracket to the power n, that is power rules. So let me recall for you power rules, then we can apply it, right? So here, if you have a bracket to the power n, I need to take the derivative of this, then your n, here is your bracket, and then to the power n minus 1, and I have to multiply that by the derivative whatever inside the bracket, So y is a function in what? Y is a function in t. Look what you have. You don't have x here, you have t. So I have to take the derivative. So dy by dt, that is y prime. Y prime is because the derivative with respect to t. Why the derivative with respect to t? Because your y is a function in t. Then how to get the derivative of this? It will be e to the power t minus e to the power minus t prime to the power minus 1, I have to take the derivative of the whole thing. So what is your n? Your n is what? Is negative 1. So I put n in front, negative 1, that is your n. And then here is your bracket, e to the power t minus e to the power minus t, n minus 1, which is negative 1 minus 1. N minus 1, negative 1 minus 1. And I have to take the derivative, whatever inside the bracket, which is e to the power t minus e to the power negative t prime. Because I'm taking power rules, f prime means the derivative, whatever inside the bracket. What is inside the bracket? E to the power t minus e to the power minus t. Now simplify this, negative sign, e to the power t minus e to the power negative t. Negative 1 with negative 1, you get negative 2. Now what do you have in the middle? Minus means you take the derivative of the first term minus the derivative of second term. Because if you have in the middle plus or minus, means you are going to take the derivative term by term. So here, negative e to the power t minus e to the power negative t minus 2. If I take the derivative of this, is this one exponential? Yes. E to the power t means I have to write what is my base, your base e, which is 2.7. What is the derivative in exponential? Should be exactly the same. It will be e to the power t ln e, and the derivative of the exponent, my exponent is what? Is t, minus e to the power minus t, exponential again, should be exactly the same, ln b, and minus t prime. I close the bracket. Minus t prime because your exponent here is negative t, so I have to take the derivative of exponent, which is negative t. So now, if I simplify this, what do you have? If I simplify this one here, it will be negative e to the power t minus e to the power negative t, and here minus 2. So what do you have here? E to the power t. What is ln e here? Is 1. What is the derivative of t? Is 1. Minus e to the power negative t. ln e is 1. What is the derivative of negative t? The derivative of negative t is negative 1. The derivative of negative t, look what you have, negative t prime, means you take negative 1 out. So what do you have inside? T to the power 1 prime. T to the power 1 prime. What is t to the power 1 prime? Just 1. The derivative of x prime or t1 prime is 1. You have negative sign outside. So negative, you have 1 multiplied by negative, so you get negative 1 here. So negative times negative, you get positive. So you have e to the power t minus e to the power negative t. And here you have e to the power t, negative sign multiplied by negative sign. You get positive e to the power negative t. Just I leave it as it is. I leave it as it is without any simple. Okay guys, so let us solve another 2 examples here so that I can wrap. So let me solve this one first, and then I go for the second example here. That is from the problem below here, from the sheet, the same sheet. So if you have h of x here equal 5th root of 7 to the power x squared plus 2x, all right? I need to take the derivative of this, right? So now let us recall, simplify this. Whenever you have radical or 5th root here, you have to switch to exponent. So how to switch to exponent? You have here m. If you have here n and you have here m, how to exponent? The exponent of this is you take whatever inside divided by whatever outside. N over m. N over m. So this one, what is n? That is whatever inside x squared plus 2x. So you have your base is what? 7. Your base 7. So you have x squared plus 2x. X squared plus 2x. I should divide this by what? By 5. That is outside 5. So here, what is inside? X squared plus 2x divided by outside, which is 5, which is 5. So now I make it from radical to exponent. Is this one exponential function? Yes, because you have your base, which is b. You should b to the power f. B is what? Is 7. That is my base. So I need to take the derivative of this. Derivative any exponential. So you have 7 x squared plus 2x over 5. Over 5. I need to take the derivative of this. Derivative any exponential should be exactly the same. Should be exactly the same. And ln your base. What is your base here? 7. So I write here 7 multiply by the derivative, which is x squared 2x over 5, x squared plus 2x over 5. Then I have to take the derivative of this. I have to take the derivative of this. So what do you have? You have 7x squared plus 2x over 5. ln 7, that is a number. Just I leave it. So that is a number. Multiply. Now 1 over 5. Some people say, can I apply quotient rule? Yes, you can apply quotient rule because x squared 2 plus 2x divided by 5. But however, you can 1 over 5, that's a constant. 5 here is a constant. I can grab 5 out. So you have ln 7 divided by 5 because I can grab 5. Then it will be 1 over 5. 1 over 5, I can grab it outside of my derivative. So what do you have inside? X squared plus 2x prime. So now just go ahead and take the derivative. So you have 7 x squared plus 2x over 5 ln 7 divided by 5, and the derivative x squared just 2x, the derivative 2x just 2, and then I leave it as it is. I leave it as it is. All right. So let me give you another example here, and then I finish this exponential part. Here is one of the problem. You have y. Another example here. You have y equal to square root of 1 minus 2x multiplied by x squared minus 2x. Right? So, okay. So now what did you just read the problem so that you know which rule I'm going to use. Square root of 1 minus 2x multiplied by e, that's exponential. So you see, when you hear multiply, means a product rule. If you have f multiplied by g, product rule here, it will be f g prime plus f prime g. If you have a product, because that is square root of 1 minus 2x, can I switch from this? Whenever you have radical, you must switch to exponent. So you have 1 minus 2x to the power what? 1 over 2. Square root of 1 minus 2x, I take whatever I have under square root, which is 1 minus 2x, the whole thing to the power 1 over 2. The whole thing multiplied by x squared minus 2x. So now I have to take the first one as f, the second one here as g. If you want, you can apply the rule here like this, or do it separate. Take f, you said f here is 1 minus 2x to the power 1 over 2. Now I need to get f prime, right? F prime. How to get f prime? You have a bracket to the power n. A bracket to the power n, that is our rule. Your n is 1, your 1 over 2. It's a bracket, so you have 1 over 2. Here is your bracket, 1 minus 2x, n minus 1. N minus 1. And I have to multiply by the derivative, whatever inside the bracket. The derivative, whatever inside the bracket. 1 minus 2x. Right? So here, 1 over 2, and here 1 minus 2x to the power 1 over 2 minus 1. So now I have to take let us apply this. It will be 1 minus 2x. Negative 1 over 2 minus 1 is what? Negative 1 over 2. So now what do you have in the middle? Minus. So I have to take the derivative term by term. 1 prime minus 2x prime. So what do you have? You have 1 over 2. 1 minus 2x to the power negative 1 over 2. What is 1 prime? 0. What is the derivative of negative 2x? 2. I can grab 2 out. What do you have left? X prime. X prime. What is x prime? 1. 2 cancel with 2. I can cancel 2 with 2. What do you have? Sign here negative 1. So what did I got the derivative? The derivative here is negative. So f prime is what? Is negative. Negative come from here. Negative multiplied by 1 minus 2x to the power negative 1 over 2. So that is our f prime. What is your f? Here. So now I have to get g. What is your g? Look what you have. I took the first term. The first term here, 1 minus 2x. That is my f. I need to get f prime here. Look what you have. Here is your f, and here is your f prime. Then you have g. What is your g? E to the power x squared minus 2x. So that is your g, and that is your g prime. That is your g prime. So that is your f prime, g prime. So now I need to get g prime, and then I go back here, replace f, g prime, f prime, g, and then you are done. So what is your g? E to the power x squared minus 2x. So this one exponential, because e 2.7 to your base here is e, a number, and here is your exponent. then what is the derivative? The derivative here should be exactly the same, exponential, and then ln e, that is your ln b, what is your be, and you have to multiply by the derivative of the exponent, which is x squared minus 2x prime. If I simplify this, you will have e to the power x squared minus 2x. ln e is 1. What is the derivative of x squared? 2x. What is the derivative of minus 2x? Just minus 2. That is your g prime. Right? So now, what is the rule? The derivative is f multiplied by g prime should be f g prime plus f prime g. And then that is what I need to, the derivative of 1 minus 2x to the power 1 over 2 multiplied by e to the power x squared minus 2x, the whole thing prime. The whole thing prime. So that is your f, and that is my g. That is your f multiplied by g. Equal what? That is prime here. Equal what? F. What is your f? Just copy f, which is 1 minus 2x to the power 1 over 2. G prime. What is g prime here? Look what you have. G prime, just copy g prime. Then just copy g prime. Then you are, so what you have, you will have e to the power x squared minus 2x multiplied by 2x minus 2, right? That is your g prime. And that is your g prime, right? And that is your f. Plus, then what is the rule? F prime. What is f prime? Look what you have here. That is your f prime, negative. So plus f prime, which is negative sign. 1 minus 2x to the power negative 1 over 2. I put it between brackets. That is your f prime. F prime. Then multiply by g. What is your g? Here is your g here. Look what you have. Your g is e to the power x squared minus 2x. And then you are done. That is product rule. You don't need to simplify here. Just leave it as it is. That is your f, g prime, f prime, g. All right. So that is very much our exponential here. And maybe I give you another one and finish the whole thing. Right. So another example here, also from the sheet. If you have e to the power, you have y equal 2 to the power x squared. So what is your b? Is this one exponential? Yes, it's 2. That is 2 here, 2. So the derivative of any exponential should be exactly the same. What is your base? Your base is 2. What is your exponent? Your exponent here is x squared prime. If I simplify this, you will have 2 to the power x squared. ln 2, that's a constant. You leave it as it is. What is the derivative of x squared? Just 2x. 2x, and you leave it like this. You leave it like this. All right? I will stop here, guys. And next time we give you the log, how to take the derivative of log.